Generalized weak monotonicity for every little v prime in capital V with f of v equals to x and f of v prime equals to y, there exists a player I such that vi prime of y minus vi of y is greater than or equals to vi prime of x minus vi of x. With weak monotonicity, we fix a player and fix the declarations of the others. Here, this qualifier is dropped. Another way of looking at this property is the following. If f of v equals to x and v prime of x minus v of x is greater than v prime of y minus v of y, then f of v prime is not equals to y. A word about notation. For alpha beta in R to the n, we use alpha greater than beta to denote that for all I, alpha I is greater than beta I. Claim 12.30. If the domain is unrestricted and f is implementable, then f satisfies generalized WMON. Proof. Fix any v prime. We show that if f of v prime equals to x and v prime of y minus v of y is greater than v prime of x minus v of x for some y in A, then f of v is not equal to y. By contradiction, suppose that f of v is equals to y. Fix delta in R to the n such that v prime of x minus v prime of y is equals to v of x minus v of y minus delta, and define v prime prime such that for all I z in A, vi prime prime of z is equals to. If z is not equals to xy, then vi prime prime of z is equals to the minima of the set chosen among between vi of z and vi prime of z plus vi of x minus vi prime of x minus delta I. If z is equals to x, then vi prime prime of z is equals to vi of x minus delta I of over 2. If z is equals to y, then vi prime prime of z is equals to vi of y. By PAD, the transition v to v prime prime implies f of v prime prime is equals to y, and the transition v prime to v prime prime implies f of v prime prime is equals to x, a contradiction. We now get to the main construction. For any x, y in A, define p of x, y is equals to the set alpha in R to the n such that there exists little v in capital V, such that v of x minus v of y is equals to alpha, and f of v is equals to x. Looking at differences helps since we need to show that the summations of ki times vi of x minus vi of y, summing for all index I is greater than or equals to cy minus cx if f of v is equals to x. Note that p of xy is not empty. By assumption, there exists little v in capital V with f of v equals to x, and that if alpha is in p of xy, then for any delta in R plus plus to the n, i.e. delta greater than 0 arrow, alpha plus delta is in p of xy such that take v with f of v equals to x and v of x minus v of y equals to alpha, and constructed v prime by increasing v of x by delta, and setting the other coordinates as in v by PAD f of v prime is equals to x and v prime of x minus v prime of y is equals to alpha plus delta. Claim 12.31 for any alpha epsilon in R to the n epsilon greater than 0 error such that 1 alpha minus epsilon is in a p of xy implies that minus alpha is not in p of yx, and 2 alpha is not in p of xy implies that minus alpha is in p of yx. Proof. One supposes by contradiction that minus alpha is in p of yx. Therefore, there exists little v in capital V with a v of y minus v of x equals to minus alpha, and f of v equals to y. As alpha minus epsilon is in p of xy, there also exists a little v in capital V with a little v prime of x minus little v prime of y equals to alpha minus epsilon, and f of little v prime equals to x. But since v of x minus v of y is equals to alpha greater than v prime of x minus v prime of y, this contradicts generalized WMON. 2. For any z not equals to x, y, take some beta z in P of x, z and fix some epsilon greater than z arrow. Fix some v such that v of x minus v of y is equals to alpha, and v of x minus v of z is equals to beta z plus epsilon for all z not equals to xy. By the above argument, f of v is in the set xy. Since v of x minus v of y is equals to alpha not in P of xy, it follows that f of v equals to y. Thus, minus alpha is equals to v of y minus v of x in P of yx as needed. Claim 12.32. Fix alpha beta epsilon 1 epsilon 2 in R to the n epsilon I greater than 0 arrow such that alpha minus epsilon 1 is in P of xy and beta minus epsilon 2 is in P of yz. Then alpha plus beta minus the average of epsilon 1 and epsilon 2 is in a P of xz. Proof. For any w not equals to the xyz, fix some delta w in P of xw. Choose any v such that v of x minus v of y is equals to alpha minus epsilon 1 over 2. V of y minus v of z is equals to beta minus epsilon 2 over 2. And v of x minus v of w is equals to delta w plus epsilon for all w not equals to xyz for some epsilon greater than z arrow. By generalized WMON weak monotonicity, f of v equals to x, thus alpha plus beta minus the average between epsilon 1 and epsilon 2 is equals to v of x minus v of z, which is in P of xz.